Hello, Heron Riverside students. My name is Miss Feck, and today we are going to be talking about 2.3, which is all about Newton's laws of motion. We're going to start by talking about how forces are vectors. Since it's vectors, we need direction, but it also means that we can add and subtract our forces. So again, last class we talked about how if we're drawing free body diagrams, we're going to see arrows representing forces. So here I see 3 newtons of force being added to another 3 newtons to the right. So then if I add these 2 arrows up, I'm going to get 6 newtons to the right. Or here, if I have a small arrow of 2 newtons to the right and 5 newtons going to the left, overall I'm going to have 3 newtons going to the left. It would be like doing 2 newtons minus 5 newtons, or plus negative 5 newtons in the opposite direction, which equals 3 newtons to the left. Or here we see 2 forces going in opposite directions, so thus I have 0 newtons total. 3 newtons minus 3 newtons, or 3 newtons to the right, 3 newtons to the left, gives you a force of 0 newtons. Here I have 4 newtons to the right plus 2 newtons to the right. Okay, so I have one arrow with 6 newtons to the right, and then a force of 5 newtons to the left counteracts it. So total, I have 1 newton to the right of force. And finally here, 5 newtons to the right and 3 newtons to the right will give us a force of 8 newtons to the right total. So that was just some review from some of the forces and vectors that we have seen. Now we're going to talk about Newton's first law. Newton's first law states that an object at rest will stay at rest, and an object in motion will continue at a constant velocity until acted upon by an unbalanced force. Unbalanced means that forces are uneven vertically and/or horizontally. So if we look at these, here, are these forces balanced or unbalanced forces? Well, we have an arrow going up and an arrow going down that cancel each other out. And then we have an arrow going right and an arrow going left based on the skier's ability to change where their force of gravity hits. Thus, these are all balanced forces. Notice that all the arrows are the same size. Here, are these balanced or unbalanced? It is unbalanced going towards the right. There is no force going to the left counteracting it. This one here, our normal force of gravity cancel out. We have a little bit of force of friction, but even more force applied towards the right. So therefore, they do not cancel out, and we have an unbalanced force going towards the right. Here, it's being pushed to the left. The force normal and the force of gravity cancel out. Although force of friction is slowing it down a little bit, the force being pushed is greater, so it's an unbalanced force. And we will skip those two. Next, we're talking about inertia. Newton's first law is also known as the law of inertia. You've probably heard this word before. But the scientific definition is that inertia is the tendency of an object to continue doing whatever it is doing. More mass means more inertia because it is more difficult to stop the thing from doing what it wants to do. And we'll talk about all sorts of examples of this in class. Newton's second law is F equals ma. So it's mostly an equation we're going to look at. F net equals the net force acting on an object, and that is measured in newtons. M is the mass measured in kilograms, and A is the acceleration measured in meters per second squared. This is an equation that we're going to use very similar to other equations that we have looked at. So if I see a word problem, I'm first going to read it, and this is about a teacher who has to move her cart from one classroom to another classroom. So she is pushing it with 0.6 meters per second squared of acceleration. Its mass is 30 kilograms. We need to calculate the net force acting on the cart. So my first thing I always do with word problems is I write the equation that I'm using. And in this case, it's F net equals MA. Next, in order to get full credit, I would need to rearrange. But I actually don't need to here because I'm solving for the net force and we already have net force equals. So then I just plug in my mass and my acceleration. So my final answer is 18 newtons. Notice that when I showed my work, I had my units included and my answer has my units as well. Another example, if we had to solve for acceleration now with that same size cart, I have my equation F net equals ma. I need to solve for my acceleration. So I rearrange my equation, F net over m equals a. So then I do 24 newtons divided by my 30 kilogram cart equals my acceleration, which here will be 0.8 meters per second squared. We're now going to talk about Newton's third law of motion. This states that for every force there is an equal and opposite force. Whenever one object exerts a force on another object, the second object immediately applies a force back on the first object in the opposite direction. These forces are equal in amount but opposite in direction. Because the forces are on different bodies, they do not add up to zero. In class, we will look at more real-world examples of these three laws, but please make sure that you have these down in your notes and then begin the IP. Have a wonderful rest of your day.